When we do a problem like this, now that we have it all set up correctly, we're going to kick it off the exact same way. In fact, really nothing is different. Look here at the first term here, look at the first term here. Maybe off to the side you think to yourself, what would I multiply negative x squared by if I want to get a 9x to the fourth? And of course you could see we would need a negative 9 to get the 9x and an x squared to get up to x to the fourth. And now I'm going to take this negative 9x squared, I'm going to multiply it by the entire polynomial on the outside. So mentally I'm doing negative 9x squared times negative x squared plus x minus 2. What I actually do usually is I do something like 9x squared times this, put the answer there, negative 9x squared times this, put the answer there, negative 9x squared times this, put the answer there. That's how I write it down, but it's not how I think about it really. So we'll get what? We'll get a 9x to the fourth, we'll get a negative 9x cubed, and we'll get a positive 18x squared. And then normally we'd be subtracting, so we're going to go ahead and draw this line and change these signs. So this positive becomes negative, this negative becomes positive, this positive becomes negative, and let's combine these terms. So these will cancel. 9x cubed and 8x squared and negative 18x squared combine to make negative 10x squared. You can kind of see how if you dropped a minus sign here, you can make the problem look really nasty or really be way off base with your answer, even though it's a small mistake. So this drawing the line and changing the signs is super critical that you make sure you do it carefully, and when you combine your terms, be very careful. This pops down, and we start the process all over again. So with a similar question, what would I multiply this by if I wanted to get this? I think I would use a negative 9, and I would need an additional x to get up to x cubed. And now I'm going to go ahead and do that whole like negative 9x times this here, negative 9x times this here, negative 9x times this here. So that's going to look like what? 9x cubed. Negative 9x times x is negative 9x squared. Negative 9x times negative 2 is positive 18x. Now I'm going to draw the line, change these signs, and combine. Hey, another rhyme. Okay, that's irritating. Negative x squared, these cancel. These combine to make negative 2x. And then this guy pops down to make up negative 5. And now I'm looking, same procedure. What would I multiply negative x squared by to get negative x squared? Well, I would use a negative 1. And I would end up with, no I wouldn't, I would use a positive 1. Silly. So that'd be a negative x squared, and positive x, a negative 2. If I draw the line and change the signs, let me give myself a little bit more room first. I'm going to draw this line, so this is going to become positive, then it'll become negative, that'll become positive. These are combined now to make, these will cancel. These guys are friends, they make negative 3x. These guys are enemies, they make negative 3. And then I, just to check, can I multiply negative x squared by anything to get negative 3x? Of course not. If the power here on x is higher than the power here, you're done with the problem. So the final answer now is going to be, this is on my remainder. Final answer will be negative 9x squared minus 9x plus 1. And then with the remainder of plus negative 3x minus 3 all over what we divided by in the first place. Now I also promised to kind of explain why this is called division, and here's the basic idea. The basic idea is if I were to take this portion of things, negative 9x squared minus 9x plus 1, and multiply it by this, negative x squared plus x minus 2, I would get an answer that was pretty close to the original problem. It would pretty much be something like 9x to the fourth plus 8x squared plus 16x minus 5. That's what this product would be. Close to that. It'd actually be off by a little bit. But once I added in this remainder and combined the like terms, it would be exactly this problem back again. So basically, the answer that I get multiplied by what I divided by with this remainder added in gives you this thing back again. That's basically how it works. If you want to see it for yourself, it's kind of a tedious process, but in a case like this, it's like 9 different calculations. probably 15 different calculations, but it's kind of cool to witness it when you see it. So good luck with that, and stick with this. It's a little tedious, I know. It is very monotonous too. When you get to the point where it feels like you're doing the same thing over and over and over again, that's good, but also just be careful that you don't drop your minus signs. Good luck, you guys.